intersection .3 Venn diagrams and operations of sets. Okay, disjoint sets is two sets that have no common elements. With no common elements. Subsets are two sets where one set is a subset of the other. You have subset A, set A and set B, and B is a subset of A. B is a subset of A. Every element in B is an element in A. Then we have equal sets. This is when two sets have exactly the same elements. So you have set A and set B. A is equal to B. And then we have overlapping sets. Set A and set B. Disjoint sets, they have no common elements, and this is overlapping sets, they do have common elements. These two sets have some elements in common. Okay, now we have the complement of a set. So you have set A complement. This means complement. An element X is in set A if X in A complement, I'm sorry, X is an element of X, A complement if X is not an element in A. So the way we look at this is the following way. This is A. Everything that is outside of A is A complement. Outside of A is A complement. Then we have intersection of sets. A intersection B. This is all elements so that they are in A and in B. If X is an element of A intersection B, then X is in A and X is also also an element of B. So this would be A, B, this region. A intersection B. Finally, we have union of sets. A union B. This is the set of all elements that are in A or in B. So here is the sets that are the elements that are in A and in B. This is in A or in B. So if X is in A union B, then X is in set A or X is in set B. Or we could say that X is in A intersection B, in which case it's in both. So the union A and B. A union B is all the elements that are in A together with B. Okay, so this is an example of doing set operations when you're given some information. Okay, you have for sets the universal set, which is given right here. A and B construct a Venn diagram and place the elements in the proper regions. So the universal set was given to us in set notation, set builder notation. Maybe we want to rewrite that so it's easier to like exactly see what the elements of the universal set are. So I'm going to write them out. The universal set contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I know these because when I read the description or the set builder notation of the universal set is all numbers that are in the natural numbers and they are greater than 0 and less than or equal to 10. So I know that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know all of these numbers have to be included in here somewhere. So there is my universal set, is the whole thing. And then I'm going to now take my sets A, B to fill this out. So first of all, I'm going to start with the numbers that are common, the common elements between A and B. So I will put those in here. So 3 is a common element, 5 is a common element, and 7 is a common element. Then this is set A and this is set B. Now, what is in A that is not already in here? So look at there and you have the element 1 and 9. So those are in A, but not in B. And then let's look at B. These elements are already included in B, but 2 is not. So 2 goes in B, but not in the intersection between A and B. Then we have elements that are outside of A and B that are in the universal set. So I know 1 is already here, 2 is already here, 3 is already here, 4 isn't here at all. So I know 4 goes outside of A and B, but it is in my universal set. So I did 4, 5 is already here, 6 isn't. So I know 6 goes outside of A and B again. 7 is already here, 8 is not, so I have to put it right there in the universal set. It doesn't matter where you put it, as long as you put it inside of this big rectangle. 9 is already here and 10 isn't. So we must include 10. So then I'm gonna do these set operations that I was asked to do. So first of all, we have A intersection B complement. What does this mean? Do the complement of this set inside. So we must do A intersection B first, because we have to follow the math rules that say do what's inside of the parentheses and then do what's outside of the parentheses. What is A intersection B? So I'm gonna write this on the side. What is A intersection B? Well, luckily, we did that already. We know exactly what A intersection B is. 3, 5, and 7. 3, 5, and 7. But we want the complement of that. What does the complement mean? It means everything that is outside of this set. Everything that is not those elements that are in the universal set, but that are not these elements. So we know 3, 5, and 7 are in the A intersection B. So we're gonna put in here all the others that are not those. So that would be 1, 2, not 3, 4, not 5, 6, not 7, 8, 9, and 10. And that's it. That's what we were asked to do, and that's what we did. Okay? Next question is A union B. So remember, A union B is everything in A together with everything in B. So what would that be? All of what's in here. Everything in A together with everything in B. We can put them in order just to make it easy for me. If you're taking a test and you put these things in order, it's really easy for me to grade it. 1, 2, 3, 5, 7, 9. Only what's inside of here, so that's it. 1, 2, 3, 5, 7, and 9. 1, 2, 3, 4, 5, 6 elements. 1, 2, 3, 4, 5, 6 elements. Always make sure that what you did was right. Then we're gonna do A union B complement. So basically the complement of this that we just did. What does that mean? Everything that is not this. It is in the universal set, but it's not in A union B. Well, we can go in order. We know it's the elements from 1 to 10 that are not in here. So 1 is already here, so not 1. 2 is already here, so not 2. 3 is already here, so not 3. 4 is not there, so 4 goes in here. 5 is already here, so not 5. 6, 7 is already here, so not 7. 8, 9 is already here, so not 9. And then 10. That's it. Those are the elements that are not in A union B. And then finally, we have this last question for this exercise, that is A complement intersection B. So the question here is to find the elements in the complement of A, so they're not in A, and then the elements that are in B, and find what they have in common. I would write a little note here to write those out first. What is not in A? Well, this is A right here. 1, 3, 5, 7, 9. So what's not in A? 2, 3 is already there. I am sorry. Yeah, 2. I got confused. 3 is already there. 4 is not. 5 is already there. 6 is not. 7 is already there. 8 is not. 9 is already there. And 10 is not. So that is the complement of A. And then B, we have it right here, 2, 3, 5, 7. So you don't have to do anything too crazy to find what B is, because that was given to you. So then what we need is the intersection between these two sets. So basically you just need to get the elements they have in common. So 2 is an element they have in common. 3 is not. I think that's the only one. They don't have anything else in common, so that is it. You're done. So 2 is the only element that is in common between A complement and B. Okay, this example number 2, use the following information to describe sets A through E, actually through C. There's only 3 questions. Through C below. So this is the information. U, meaning the universal set, is the set of U.S. corporations. A is the set of U.S. corporations whose headquarters are in the state of New York. B is the set of U.S. corporations whose chief executive officer is a woman. And then C is the set of U.S. corporations that employ at least 100 people. So the question is, first one, A intersection B. That means what A and B have in common. So A and B are here. Again, A is U.S. corporations whose headquarters are in New York City, in the state of New York, I'm sorry. And B is the set of U.S. corporation whose CEO is a woman. So the way we write this is one sentence that describe all of the U.S. corporations that are in both of these categories. So this would be the set of U.S. corporations, located in the state of New York, whose CEO is a woman. So this right here have both of these conditions because it is an intersection. It's an intersection set. And then we have A union C. So A, which is again the U.S. corporation whose headquarters are in the state of New York, and C is a set of U.S. corporations that employ at least 100 people. So this set A union C is all of these together with all of these, okay? So this would be the set of U.S. corporations located in the state of New York, this is very important, or the set of that employ at least 100 people, or that employ at least 100 people. The key here is that you said or, because that means these could be, or these could be, or both. So that word, that is a big, it's a much bigger set when you say or. And then we have C, which is B intersection C complement. So let's see what this means first, and then we'll write it out. B is the set of U.S. corporations whose chief executive officer is a woman, and C is the set of U.S. corporations that employ at least 100 people. So what does that mean? C complement would be the set of U.S. corporations that employ less than 100 people. Because at least 100 people, that means 100 people or more. So the complement of that is a set of U.S. corporations that employ less than 100 people. So let's write this out. This is an intersection, so we know we're looking for U.S. corporations that meet both of these conditions. So we will say this is equal to the set of U.S. corporations with whose CEO is a woman, and that employ less than 100 people, and that employ less than 100 people. Now we're going to go to example number 3. Okay, this is example number 3. Use the Venn diagram to list the elements in the set in roster form. So we're given a Venn diagram, and I forgot to do this when I drew that, but we must remember that the whole thing is the universal set. Now, this Venn diagram contains elements, and these elements are letters. In the past, we were doing examples with numbers. This one contained letters, and that's okay, because elements can be symbols of any sort. They can be letters, they can be numbers, they can be animals, they can be anything. So let's go ahead and answer the questions based on this Venn diagram. So the first question is, list the elements in set B. So we have to go to B. This right here, this circle, is set B, okay? So we're gonna go ahead and put in and list all the elements in set B. So we have C, E, M, V. C, E, M, V. That's it. That's all they asked for, or that's all I asked for. That's all that the answer is. C, E, M, V. Now, here we have another example or another question where it says A intersection B inside of the parentheses and then the complement outside. What does this complement mean? The complement of the intersection. So it is good to do the inside first. What is A intersection B? Remember, those are the elements that A and B have in common, which is this right here, M. A intersection B is M, comma, V. I wrote it here in tiny because now the answer to these is everything you see except those two, because it is the complement of that. So it's everything that is not this. Okay, so we can go ahead and write it. I'm going to start with these and then go here and then go up here. I'm going to remember not write these two because it is the complement of that set. So we go in here and start A, B, W. The order really doesn't matter. When it's numbers, I like to put them in ascending order, but it's not required. I just like to do it. Then we have E, C, and then we have S, R. And that's it. Oops, comma. So those are the elements that are not in A intersection B. So then we have example C where we have to do A union B. A union B is everything in A together with everything in B. So all we have to do is list all of these elements that are inside of these two big circles, okay? And again, the order in which you write them doesn't matter. What matters is that you write all of them and none of them you write twice, okay? So you list each one only once. A, B, W, A, B, W, M, V, M, V, E, C. Those are the elements that are in A union B. So now here it's very lucky that after this question we got this question because we want to do the complement of A union B. We already know what A union B is, which is that right there. So the complement is everything that is not that. And we know that this right here is everything that is inside of here. So what is outside is only S and R. Done. Okay? That is the complement of A union B. Again, what is not in this set. And then last but not least, example E, where we have to do A complement intersection B. So I like to, when I have this, I like to list what's in A complement, what's in B, and then I'm gonna do the intersection between those two sets. What's in A complement? It's what's not in A. This is A. So A complement is gonna be ECSR. ECSR. What's in B? MVEC. MVEC. So what do they have in common? What they have in common is EC. That's it. So that is the answer for A complement intersection B. EC.